Day 13 of Advent of Code 2024 is here, so let's try to solve it. I've already pre-read this description, so I will just give you some summary. So this day we are working with some claw machines, which have two buttons labeled A and B, and each of the buttons moves the claw in some way. Button A is more costly, it costs 3 tokens to move it, and button B costs 1 token. Now the prize is located in some specific coordinates, like here, and we have to move the claw exactly above the prize so that we can win the prize. And each of the buttons moves the claw in some way, so we need to find a way to combine the button presses so that we end up above the prize, basically. And in many ways, many cases, it will not be even possible. So in this sample input, it's possible in the first and in the fourth, I think. But in the other claw machines, you can never win, basically. So it's very important for us to figure out how many times you have to press the button A and button B, and then calculate the total number of tokens that it will cost us. And the final output of our program will be the fewest possible number of tokens that we have to spend to win all the prizes that are available in the claw machines. So my approach for this will be to try to solve it using linear algebra, to take the two equations, one for the x coordinate, one for the two sets of equations, one for x coordinate, one for y coordinates, and try to find the solution this way. And this should be doable, especially if there are not multiple solutions for each of those claw machines. So that's what I will try to do here. So here we go. So we will have a public record claw machine, which will have a point button A, point button B, and point price. So this will be our claw machine, and we will have in the solution we will be reading in the claw machines and try to read them in. So I will have a bool try read claw machine, which will have stream read, yeah, exactly like this. And basically what we will do, if the input is empty, we will return false, that's right. But if it's not empty, then we will read the format here. So first will be button A. So A line, B line, and the price line. That's right. And finally, we need to read line because there is an empty line at the end after each. Actually, we can read it. Yeah, we can read it afterwards. Yeah. So there is an empty line after each of those claw machines. So we just can, or we can do it like this. Be like this. Read line is line. All right, so we can do. So let's do it this way. So just to get rid of the white space, if a line is null, we return false. If line string is null or empty line, we read a new line as well. So we get rid of the empty line between inputs. And I will just have to use it here. So while try read. Yes, that's good. So we read the claw machine and we solve claw machine. Price. And if the price will be greater 0, then we add it to some total. So we'll have a total 0, and we will add up the total plus equals price. So that's what we will have, or greater than equal, because potentially we could start on 0, 0, and the price would be on 0, 0, then the price will be 0. But return total to string. Actually, yeah, it can be just greater, because if it's 0, then it doesn't add up anything to the total. So this will be it. We'll have my method called private long solve claw machine, and it's gonna be claw machine like this, and it will do something with the, we'll solve the equations basically. So that's what we have. Then we need to read the claw machine. So what we have to do is button align split it by colon, parts, then split parts 1, so that's the second part, we will split by comma. So actually you can do it here, 1 split by comma, and then we have the parts, each of them is x plus and y plus, so ax equals int parse substring 2, so we start at the index 2, so we skip x plus and y plus, and the same thing for y, so that's for y, and now we do the same thing for button B line. We just reuse the parts there, B, Y, read it, and finally the price will be this, basically the same thing. So price line, and we have price X, price Y, and we get all the inputs. So now we can use them here. So it's going to be button AX, button AY, button BX, button BY, and finally price X, price Y. So that's our claw machine. We return it and we're done. So now that we have it, we need to solve the equation. So the equation looks like this. So we have to press B times BX plus, or sorry, A times AX plus B times BX to end up with price X. And for Y coordinates, it's going to be this way. So we need to solve for solve these two equations. So to solve it, we will have A equals price X minus, yeah, thanks Copilot for the help here. So for B, so now we put this into the second equation. So it would be price, divided by ax times ay equals bx, b plus b, so price y. So we put it there. So now we have the only thing that we need to figure out is the b, which is this whole thing. So price y minus this divided by by, and that gives us b. And once we have b, we can figure out then that a equal, we can just put the solution here to get a as well. So that's our equation. So now we need to figure out if this solution is going to be integer solution. If there is an integer solution for this, then it means that it's solvable in an integer number of presses. So what we do is p equals price y minus, it's actually Copilot will fill that for me here. So, oh, what did I do here? That's wrong. Right, I did not I have to put this on the left side as well. So let's see. It's gonna be price. So let's do price x divided by x minus b times bx divided by x and y, and so that's price a. Okay, that's fine. So now we have we will have b times bx divided by ax. So that's the first one, plus b times by equals price y minus this. And now we need to, exactly like this. We have to take the b outside. So this is the multiplication, and now we divide it. So this is the result, essentially. A little bit more complicated than before. So now we do b equals, and I think Copilot will handle that. So ax, ay divided by bx and y, right? So we have this. And based on that, we can then use a equals a price x minus bx ax. Okay, so now that we have those, we can check if it's actually a correct solution. So we want to see if actual x equals yes, this, and actual y equals this. So if actual x equals price y, then we had the right solution. So in that case, we return a times 3 and b plus b, because a costs 3 tokens, b costs 1 token, and ultimately we return -1 if it's not solvable. So I hope this is correct now. So let's see if that is the case. So I will take the sample input there. And let's see what happens. So we have some error there. Oops. So what do we have there? Right. Additional parentheses. Okay. So let's see what happens. Right. So, oh, right. We have to make sure that we trim these as well. So trim, otherwise it wouldn't work. Trim. And that should be better. Right, so it's doing something at least. Let's see if it's reading the input correctly. So button A, 67. What is it? 22 and 67? Where is it coming from? There's nothing like that. Oh, 22. Oh, all right. All right, so that was my misunderstanding. So 22 B X A Y. Okay, so I'm seem to be reading it other way around, because BX. Oh, I switched up the order. That's now that's better. So that's A and B. And we will check if it's now okay. So A, B, price is this. That should be okay. So now let's see what the solving itself looks like. Okay, that's not what I wanted, definitely. So I must have done something here wrong. So let's confirm our equation. So we have this and this. So now price X minus this divided by AX is the first one. We take the A and replace it in the second one. So that's this whole thing goes here times AY plus BY price Y. So now we need to get B's on the on one side. So price X divided by AX minus BX divided by AX times AY. That's okay. And actually that's, of course, that's kind of basic mistake here, because I'm working with doubles, the whole thing, and then finally need to convert to integers. So essentially, let's do price Y equals double price Y, price X. I just use AX, AY, BX, BY, just to use double versions of those variables. So like that, because otherwise I would be doing integer-based divisions and ultimately end up with incorrect result because of that. So now this will be much more correct. So X. So actually what we get is B and A as well, we can do math round that number. It's gonna be to a long, so I will do long here, and actually it's gonna be small number because they said max of 100 presses, but let's see, long. And we also want to check if and actual and a greater than 0 and or greater than equal to 0 and b greater than equal to 0, because we don't want to have a negative number of presses. So hopefully this will be okay. Yeah, it seems to make sense, at least to me. Number of presses, 2000. That's a high number again. So this is not a correct solution. And we are wrong again. Okay, what is happening there? So what am I doing wrong here? So we have this AY plus BY. So now we put B times BY here. And what is that? Oh, wait. There is the problem, right? What happened here? It's completely wrong. So this should be okay. I again trusted Copilot when I should have, I guess. So this should be times AY, and it should be also minus. So minus, so it should be B times BY minus yes, that's, yeah, definitely it should be like this. So B times BX divided by X times AY equals the price. Let's stop it anyway. So this, and now, yes, that's much better. So B times BY minus BX divided by AX times AY equals this. So B equals, so AY divided by BY. Okay, that seems better, hopefully. So let's redo this. Does it correct itself? So yes, AY divided BY minus BX by X AY. So hopefully now, if I didn't do another mistake, which is definitely possible, 496 is the result. 496, which is a little bit more than I would like. So let's see what is the result for each of them. So for the first one we have 40 presses and 80 presses. So that's this one, right? 40 and 80. 80 and 40, that's correct. So the result we have, let's do it here. So the total there is 200. But that's for the last one, right? That's claw machine. No. Is it? So let's try again completely. So once more. So the first one is 200, which is not right. So what's the problem there. So we have button A is 2267. Still switched up? Oh, wait. Wait. Oh, shoot. So what I'm doing here is... Oh, I completely somehow mismatched this. And now, that is better. So, shoot. Not a lucky day today. Many rookie mistakes. So, 280, that's better. And 200 for a total of 480. So that's better. So now let's see what happens if I use the full input here. We'll see if at least on the full input it will run first time. So 37,297, which is correct. Okay, that's the first part done. So now let's switch to part 2. In part 2, we discovered that due to conversion error, the position of each price is actually this higher in both X and Y. So we need to kind of imagine that those numbers are this much higher, and we need to make many more presses than we originally had to. So to do this, we try to adjust our solution, but keep most of it as it is. So the claw machines will read the same way as we did before, but the solution will be a little bit different because we will have to add this to the price X. And then we calculate things, and then we will probably we can try it for the first run. See what happens on the sample input. So we do test data. So it's 0. So we probably overflow somewhere. I'm guessing. So data. So actual Y, actual X times BY. Okay. So let's do simul. Okay. So what is the result when we run it here? So nothing seems solvable then. Okay. But it should be solvable for the second machine, they said. So let's try to see what happens for the second one. So first one, second one. All right. Yeah. Yeah, that's pretty important. I'm checking against the wrong number. So this is the number that we are checking against. Should be better. Okay, so now it's doing something. So let's try to run against the big input. So this huge number, which is correct. Okay, so all right. Today's problem was tricky because I made a lot of mistakes during my algebraic equation, also thanks to Copilot, but still, I should have been more careful about this. And we have finally solved the 13, even though it was a bit tricky. We have the solution, so we have both parts of problem 13 done. So I will also make another video as usual to see if ChatGPT can handle this one. It seems that it should. This is a very algebraic problem which has just mathematical solutions. So this is really well suited for ChatGPT. So I think it should be doable, but we'll see. So I will see you in that video, and until next time.